Hello, Geometry. Today I'm going to go over some notes on section 5.3 of your student journal. I am on page 135 of your student journal. So turn there now and pause this video if you need to. Okay, so for the definitions, I'm not going to go over congruent figures or rigid motion. Those are previously defined vocabulary terms that we have talked about. But I may add some other information up there, so don't just completely cross it out. Today I'm going to start introducing one of the ways that we can determine that two triangles are congruent. We had previously determined that two triangles were congruent back in section 5.2 by showing that all the side lengths and all the angles were congruent. And by knowing all of that information, like in this picture here, we were able to say that they were congruent. Well, you don't actually have to know that all corresponding parts are congruent in order to state that two triangles are congruent. So remember, this is specific to triangles. There are certain theorems that allow us to assume that and know that two triangles are congruent based off of the congruencies that we have. The one that we are going to be talking about today is what we call side angle side. Side angle side, abbreviated SAS, is a congruence theorem that allows us to state that two triangles are congruent. So this is something that allows us to state two triangles are congruent. There are others that we are going to learn in other sections, but for today, we are just concentrating on side angle side, which we abbreviate SAS. Okay, S standing for side, A standing for angle, and S standing for side. It's very specific that the way that the name is given to you, and I'm going to explain that with the definition that's given to you here below. It states that if two sides and what we call the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the two triangles are congruent. Okay, so I'm going to talk about what they mean by included angle. Okay, so the included angle definition. So the included angle, I'm going to underline that, of two sides of a triangle is the angle formed by the two sides. So let's look and see what that looks like in a picture. So using these two pictures up above. Okay, so in this picture here, these are two congruent triangles. And you'll notice that not all of the sides and angles that are congruent are marked. There are only three things marked. There is a side marked, an angle marked, and another side marked in each of these pictures. Okay, so over here, what we have congruent is we have a side, and the sides that we know are congruent are AB and AB and DE. So that's this and this. Okay. We also know that there is an angle congruent. The angle that we see is congruent. We can use just one letter to name those angles since the vertex does not share other angles. We can say that angle A is congruent to angle D. And that's this angle and this angle. We also know that a side another side is congruent. That's those sides being AC congruent to FD. Or sorry, DF. I wrote that out of order. DF. So that's this side and this side, the one with the two tick marks. Okay. Now, angle A and angle D, these are what we call included angles. Okay. It's the angles in between the two congruent sides. So I'm going to write that again. The angle in between the two congruent sides. I know I already defined that, but I wanted to sort of write it in a different way. But that's an example of what an included angle is. Angle B and angle C, those are not included angles because they are not in between the two congruent sides. Okay? So that's what they mean by included angle, right? So this is a perfect example of two triangles that are congruent. So because we know all of this is true, we can make a triangle congruency statement, okay? We can say that triangle ABC is congruent to, and we want to make sure we write this in the correct order. Since I went from A to B to C, for the other triangle, I have to match up my corresponding sides, right? I'm going to go D to E to F. So D, E, F. That's one triangle congruency statement. But this is what they mean by side, angle, side. And you literally have those congruencies in that order. You have a side congruent, then an angle congruent, then a side congruent. So this is what the side angle side congruence theorem is saying. And if you know this to be true, you can assume that your triangles are congruent. Okay, so we're going to look at a couple of examples. Now, these examples that I am going over, you do not have in your student journal. So I just want you to listen and follow along. You will see examples similar to this in your big ideas practice. So it's important to listen and pay attention. If you want to write them down, you can, but you don't have to. Okay? All right. So it says in numbers 1 and 2, decide whether enough information is given to prove that the triangles are congruent using the SAS Congruence Theorem. So you can see that they use that abbreviation. That's fine. I'm not even going to worry about the theorem number. Okay, and then it says explain, and I'll sort of just explain that to you. All right. So in number 1, I can see that I have these two sides congruent. I have these two sides congruent. So far I have a side and a side congruent. I need to make sure that if I have an angle congruent, that the angle that's congruent is the included angle. So I can see that I have this angle congruent to this angle. I can see that that angle that is congruent is the angle in between the two congruent sides. So since it's in between the two congruent sides, I have a side, an angle, and then a side congruent. So the answer to number 1 is yes, it is in fact congruent. They are congruent by side, angle, side, or SAS. You don't need to write it out. Okay, let's look at number 2. In number 2, I do have this side is congruent to this side. The double tick mark means those two sides are congruent. I don't have any angles that are congruent, but I do know the vertical angle theorem, which tells me that all vertical angles, meaning this angle and this angle, are congruent. Well, that angle, if you notice, is not the included angle. The included angle would actually be this angle right here. That would be an included angle, but I don't know that that is congruent to the other included angle, right? Since I don't know those are congruent, I cannot assume it, and I have no way to figure out. The only angles I know that are congruent are these vertical angles. So in this problem here, I do have a side and an angle. Put that here. But there is no theorem that is side-side angle or the other way around. Okay, in order for this side angle side theorem to work, it has to be the included angle. So the answer to this one is no, the triangles are not congruent by side angle side. And they're actually not congruent at all. There is no theorem that involves a side, and an angle without the angle being the included angle. Okay. Let's look at this. Actually, let's go down to these two problems because these ones are more like the ones up above. So in exercises 1 and 2, this is again stating if they are congruent using side angle side congruency theorem. So I'm going to cross out that number. Okay, so let's see what we have in this problem here. Whoops, not sure what happened there. Okay, so in this problem here, okay, one thing that I know is obviously all the things that are given to us, right? But in addition to what's given to us, I know because of reflexive that any side is congruent to itself. So this side that I've highlighted in pink is actually shared with both triangles, but it's the same side. So it's the same size, so it's congruent to itself. So that is another congruency that we know. And what I have so far is not going to be able to tell us that it is congruent using side angle side. But I do know one more thing. If you remember the third angles theorem, which states that if two angles are congruent in two triangles, that the third angle is also congruent in each of those triangles. Okay, so since this angle is congruent to this angle and this angle is congruent to this angle, the third angle of each of those triangles has to also be congruent. And if you notice, that angle, that third angle, is the included angle. It is in between. It is in between those two sides. So this side and this side, right? It's in between them. So I can definitely say that yes, this is congruent by side angle side. Okay. And then number 2 over here, I can see that I have some congruency marks here. Looks like this side of this right triangle is congruent to this side of the right triangle. This side is congruent to this. I have this angle congruent to this angle. They tell me that both of these are 90 degrees, which means that they are congruent to one another. And because of the third angles theorem, I can state that the third angle of each of these triangles is also congruent. So just going and marking my picture like crazy, right? So you can see again that this angle right here, this angle here, and this angle here, those happen to be the included angle of our two congruent sides. So our two congruent sides being, my pencil doesn't want to change, the two congruent sides being this side and this side. Those are the sides, and that's the included angle. Knowing this side and this side, that ends up that being the included angle. So for this problem, yet again, you can say yes, it's congruent by side angle side, because we had all of the other information congruent. Okay, so you got to pay attention and watch out for that third angles theorem. We also want to watch out for vertical angles could definitely show up as well. Okay. All right. Let's take a look at numbers 3 and 4. These are just some little extra examples here. Number 3, dealing with a circle. It says use the information given to name 2 congruent triangles. So looking at this circle, they should have told you that O is the center. So O is the center. I wish they would have said that. So we know that O is the center. If O is the center of the circle, that means that any segment going from the center to the outside of the circle is going to be what we call a radius. And the radius of all the radii of all circles should be congruent here. So any radius in a circle is going to be congruent. So from O to A, O to B, O to C, those are going to be congruent. Okay. So that actually gives you enough information to state that you have 2 congruent triangles because I have these 2 angles congruent as well. So the 2 triangles that we're looking at are going to be this triangle here, right? And then the other triangle that we're looking at is this triangle. Apparently I can't draw in the lines. It's kind of thick. That's probably why. Would be this triangle here. Okay. All right. So now we need to create a congruency statement. I know that these triangles are congruent because I have a side, angle, then a side. And on the other triangle of a side, angle, and a side, where that angle is the included angle, meaning it's between the 2 congruent sides. So I can definitely say that triangle, and I'll go A, O, B is congruent to triangle C, O, B. That's one congruency statement that you could write. Paying close attention that my corresponding parts are in the same position in each of the triangle names. So now that we looked at number 3, let's look at number 4. In number 4, I can see that I have some congruency marks here, here, and here. Just because it's marked congruent does not mean that you're going to use it. Okay. I do have this angle congruent to this angle, which is congruent to this angle as well. Other things that I know are congruent because of reflexive property. I know that BE is congruent to itself. The other thing that I know is that CE is also congruent to itself. So I'm going to use 3 tick marks there. So what you're doing is you're looking for the 2 triangles that have the same congruency marks. Okay, so looking at the 2 triangles here, I can see that this triangle here, ABE, and this triangle here, BCE, have enough information for me to use side angle side. Okay, so and you can see that AB and BC are congruent, BE is congruent to BE, and both of these included angles represented at angle B are congruent as well, and that those angles happen to be the included angles. So we can definitely say that these 2 triangles that I have highlighted are congruent. So now naming these, making sure corresponding parts line up. I have A, B, E. When using side angle side, I like to put the included angle in the middle. When naming the triangles, it makes it a little bit easier. So since A to B corresponds with C to B, I'm going to go triangle C, B, E. And definitely both of these are congruent by side angle side. Okay, so those are all the examples that I have. You are now to go to your Big Ideas assignment, practice 5.3, and complete those problems, and best of luck with your practice.